So with respect to modular arithmetic, we have defined how we are actually doing additions of two numbers, like when you have two numbers to be added modulo c, we basically mean that we first take the remainder and then add the remainders and then again take the remainder mod c. So we discussed that we would be finding out the remainder, so we would be finding out a mod c plus b mod c individually and then taking a modulo, right? Similarly, we could do subtraction. We could open up the modulo inside it, first take modulo both of them and then subtract and then again take a modulo. We discussed that we could multiply two numbers. Now one more operation is left, right? Divide. Let's say you have a fraction a by b. How do you represent this in modulo terms? How do you divide numbers in modulo? So you can't directly do that. You first find out the remainders and then just divide it, right? You cannot do, like, let's suppose the numbers were let's take 10 and 7 and you had a remainder of, like, let's suppose modulo, let's take this 10 5 modulo 4, or rather let's take it modulo 3. Okay, so we have 10 5 and we take modulo 3. So if we divide it directly, we get 2, right? We get 2. If we divide it directly, we get 2, and then 2 modulo 3 is actually equal to 2, right? But if we take modulo first, it will be 10 mod 3, that is 1, and 5 will be 5 mod 3, that is 2, so that is half kind of thing. And then if we take modulo, that doesn't make sense, right? It is no longer divisible, so we cannot open up modulo inside divisions directly, right? So how do we perform these divisions in case of modular arithmetic? So remember, why are we doing this modular arithmetic? We really need to find the answer of a large computation modulo some number c, right? So that in each of the steps when we do such operations, instead of doing them and making variables overflow, we take a modulo so that they don't overflow and it is still inside the range. Why generally we have this modulo of 10 to the power 9 plus 7? That is because this number is a prime, and when you have prime, there is a nice property that 1 p square p cube up to p to the power some c minus 2, okay, all these numbers for any p that is co-prime to c will be different in mod c domain. Okay, so generally the problems ask you to find out modulo this prime. That is because every different number in this modulo can be a possible answer. So if your computation is not exactly correct, you will get some wrong answers. Okay, and 1 p square p cube p to the power c minus 2, all of these things will be a different number when p and c are co-prime and you are doing like some modulo c. So since if you take c as a prime number in this modular division, then everything will remain co-prime for sure. So all these will be a different number in the modulo domain, so you won't get 0 directly in some cases, right? So that's why this c is generally taken as a prime. So now even if we have a prime, how do we find out this division in cases? So let's look at that. Let's try to think about what do we do in case we have some prime modulo. So now what we want to find out is, you need to find a by b. You need to find out such a number, right? But this will be a fraction, so you will be asked to find out what is the fraction. So in problems, when you need to find something like this, so you will be given, this is after reduction and everything, this is of the form p by q, then report p into q inverse, okay, mod, let's say 10 to the power 9 plus 7. This will be the problem, that you need to report p into q inverse. Now what is this q inverse that we're talking about in this? Let's look at that. So whenever you have a division in the operation, instead of doing the division, we find out the inverse of b and multiply it with a. So we do this, which is same, right? Like b inverse is like 1 by b and multiply that and take modulo, right? Modulo sub c. So we would be interested in finding out this inverse, b inverse, and multiplying that with this. Now what is this inverse? So let's look at that. So a modular multiplicative inverse of an integer a, let's take an integer a, is an integer x. Let's suppose there is an integer x which is a modular inverse of a, such that a multiplied by x is congruent to 1 mod c. Now what is an inverse in general terms? So a multiplied by 1 by a is equal to 1, right, in general mathematical terms. Now in modular arithmetic as well, a multiplied by its inverse, so this is inverse, is congruent to 1 mod c. You have to find such an x, so that will be the inverse of a. So that this is the definition of modular arithmetic inverse. Okay, now this x is the inverse, right? So we need to find such a x such that a multiplied by x is congruent to 1 mod c. So this will help us with expressions like you have some a by q mod c, you need to find this mod c. So rather than this, you find out p multiplied by q inverse. So from q you need to find out the q inverse and then rather multiply that. And we know that we can easily multiply things in modulo domain, right? Multiplication of things is easy. Okay. So how do we find this x for a particular a? So let's quickly take an example. Let's say there is a number 2 whose inverse you need to find. What is the inverse of 2? Now in general mathematics that would be 1 by 2, but we don't have fractions in modulo domain, right? That's an integer partition of space. So how do we find 2 inverse? So what is the inverse of 2? So 2 multiplied by some x is congruent to 1 mod some c. So let's try to find out what is the inverse of 2 in domain of 3. Okay, so what is the inverse of 2 when you take modulo 3? So what is 2 inverse? So this x will be 2 inverse modulo 3. So x is congruent to 2 inverse modulo 3. So what is this number actually? Like this is not a number, right? There is an inverse over here. How do you find out this number? So we try by inspection first of all. Can we put 0? No, because 0 times 2 would be 0 and then that is not true. If you put 1, that's not working. If you put 2, 2 times 2 is 4 and then 4 modulo 3 is 1, right? So we find out that x is equal to 2. So in fact 2 inverse modulo 3 is equal to 2. Okay. Similarly, let's take some example. Let's say we need to find out 3 inverse modulo 5. Okay, what is 3 inverse modulo 5? Like what do you multiply with 3 so that you get 1 modulo 5? That's the definition, right? This is 3 inverse modulo 5. So whatever satisfies this, whatever this number is, will satisfy this expression that 3 times x is congruent to 1 mod 5. And what is this value of x that you can think of? Can you think of some value of x that will satisfy this expression? Again x equal to 2, right? Because 2 times 3 would be 6 and 6 remainder with 5 will give you 1. So this we are doing currently as by manual inspection. We'll look into how to find this out for every a and x. Okay, so x is equal to 2, right? So now we are clear with the definition that what is a inverse modular m, that such an a multiplied by this x will give you 1 mod m. The value of this x is equal to this, like this is x. Okay, this is what we're talking about, modular inverse. So what do you multiply with something so that it gets this? And this is the inverse that we will find out in the expression. So whenever you have say a probability kind of problem where you generally have like a fractions, right? In probability you generally get some fractions kind of thing where you have like the answer in p by q form. So in the problem you will be asked P times Q inverse, and for finding out this, what you can do is that just find out the Q inverse and multiply that with Q, and then report that modulo sum C that is given to you in the problem. Okay. Now how do we find this modulo inverse in general cases? So we will take one assumption that since in most of the problems this modulo that is given to you is a prime, we will assume that C is always prime from now on. Okay, so we need to find out some way to calculate A inverse modulo some prime P. Okay, find out A inverse modulo prime P. Okay, so to find out this, we will use a theorem. Okay, so another theorem, something called Fermat's little theorem, which says that if P is a prime, then for any integer a to the power P minus a is divisible by P. So P divides this. This is what Fermat's little theorem says. Okay. So this thing holds for any integer a. Okay, so this is what Fermat theorem says. Now in general, when you will need to find out the inverses and stuff, what you can do is that you can find out P, this P given a to the power P minus 2 mod P. Okay, you need to find out this number, and what I claim is that this is your inverse. Okay, now why is that? Why is this your inverse always? Let's look into that. So this a to the power P minus a, P divides this, right? P divides a to the power P minus a. So in most of the problems a will not be equal to P. So P, since P is a prime, if P is a prime, then denominator would not make sense, right? When you have P by Q format, if a is exactly equal to Q, then things would not make sense. So that denominator will be given in such a way that it does not get this prime. So a will always be less than P. Okay, a will always be less than P whenever you need to find this out. Okay, so when a is less than P, you can write this as a to the power P minus 1 times a. P divides this, right? Now since a is less than P cannot divide this, right? So P has to divide this part. So P divides a to the power P minus 1, right? Clear up to this? Now if this is true, then we look at what does this mean. P divides a to the power P minus 1. So we can write it in this way, that mod P, right? So P divides this is same as this, right? Remember the alternate expressions that we have in modular domain. Also, since this is congruent to 0, we can add 1 on both sides, and we can write, because the remainders shift equally when you add some constant, right? So this is congruent to 1 mod P. Now we want to find A inverse mod P, right? So what is this number over here? So A times X is congruent to 1 mod P, right? This is the definition of inverse, and we know that a to the power P minus 1 is congruent to 1 mod P. So we can write it like a times a to the power P minus 2 is congruent to 1 mod P. It's just separating these two numbers once, right? So for any prime, this part is a potential value of X, right? This is a potential value of X. So we can say that X equal to a to the power P minus 2 satisfies this expression. So in fact we will use this value a to the power P minus 2 mod P as the inverse of A. Now in generic senses, these values of x is not unique, like you have multiple solutions to this. Okay? You have multiple possible solutions for this x, but when you reduce all of them mod p, they reduce to the same value. So inverses are unique when you have the prime domain, okay? And they exist. So this is what we would be using. So now, from now on, whenever we say that we need to use inverse, we just report a to the power p minus 2 mod p whenever we need to find a inverse mod p, right? But remember this very clearly, that this only works if p is prime because of Fermat's theorem, okay? So if we quickly go back with Fermat's theorems and all of these fractions and inverses back, now when you need to find a division, when you have some expression and you need to find the division, rather than dividing the numbers, you take the inverse of b and multiply it with a, right? This is what you do. So now in any problem, when you need to code things up, you will, if you need to add, just make sure that this doesn't overflow. If it's overflowing, then you can use this property and take the modulo inside and take a modulo and then take another modulo after adding the remainders. Similarly for subtraction or multiplication as well. For division, you just need to find the inverse of b and then multiply it with a. And remember, whenever you need to find inverse, most of the problems that you face will have c as a prime. So you just need to find a to the power p, a to the power, let's say c is a prime, so a to the power c minus 2 mod c. You just need to find this number and that's your inverse. Find this number, multiply it with a, and that's your answer for this, right? Okay. So these are the all operators that we have in modular arithmetic. So these are the general mathematical operators that you would be needing in programming, and whenever you see these expressions in the problem and you need to find the answers modulo some value, you will use these properties that we discussed in over here to calculate the answer without any overflow, right? Because once the numbers get overflowed, the values are not correct anymore, okay? If the numbers overflow, the values are not correct anymore and you will never get the same correct modulo value in all cases, okay? So just to be safe with overflow, we are using these modular arithmetic, okay? Now, still there is a very big problem in calculating the inverse in this way. We need to find b to the power c minus 2, right? Now let's suppose I ask you to calculate 2 multiplied by 3 inverse modulo 10 to the power 9 plus 7, okay? So this is basically 2 by 3, right? You had some answer 2 by 3, you need to report that modulo 10 to the power 9 plus 7. So what you do is that you report it like this, right? And you need to find 3 inverse modulo this, right? So what is 3 inverse modulo 10 to the power 9 plus 7, okay? So now you will need to find out, how do I find this? With the theorem that we discussed, we know that this is prime, so we can write this as 3 to the power 10 to the power 9 plus 7. This is the prime, minus 2, right? Modulo 10 to the power 9 plus 7. Okay. Now, how do you calculate this efficiently? So that would be seen in the next video. Thank you.